Coaching Center. So today I'm going to explain your 12th standard physics first chapter, that is electric charges and fields, part 2 video. So let us come to the chapter. So next is Coulomb law. Coulomb law is a quantitative statement about the force between 2 point charges. The force between 2 point charges is says up in the Coulomb law, and and these two charges Q1 and Q2 are separated by a distance or in a vacuum. The magnitude of the force between them is given by, like this it is given, F is equal to K, the constant is taken, and Q1 into Q2 by R2 is the R whole square is the thing we find. So when the separation between two spheres is much larger than the radius of each sphere, the changed sphere may be regarded as point change. The changed sphere may be regarded, they can be said as point change. And the symmetry, the charge on each sphere will be q by 2. The charge on each sphere will be q by 2 we have to take, and also the charge on each sphere will be q by 2 we have to take, and repeating this process we can get charge by q by 2, q by 4, etc., like that. Only continuously we will get the number. So Coulomb's law is simple mathematical statement, was initially experimented arrived at the manner described above. So while the original experiment established it was a macroscopic scale, so it has also been established known as a subatomic level, or minus 10 to the power minus 10 meter. So Coulomb discovered his law without knowing the explicit magnitude of the charge. So without knowing the accurate magnitude of the charge, he made the Coulomb law. It is in fact the Coulomb law, it is the other way around. Coulomb law can now be employed to furnish the definition, or can be used to explain the definition of unit of charge. It is used, and here K is taken as constant, and SI unit of K is about 9 into 10 to the power 9. So Q1 is equal to Q2 is equal to 1 Coulomb, R is equal to 1 centimeter. So F is equal to 9 into 10 to the power 9 Newton we have to take, and that we have to take F is equal to 1 by 4 pi V0 by Q1 into Q2. So therefore E0 is equal to 8.854 into 10 to the power minus 12, because C2 n minus 1 n square is the, so E0 is called as the EO is called as the permittivity of free space, and the value of E0 is, this is the value of E0, or permittative of free space we also call it as. The next is, since the force is a vector, it is a vector quantity, it is better to write Coulomb law in the vector notation. So therefore we have to write it as R is equal to R1 minus R2 minus R1, and one is and leading that we can denote it as R12 is equal to R1 minus R2 is equal to minus R21 we can denote it as. And like that only we so force F2 F21 is equal to 1 4 pi E0, or the permittative. Here we got no permittative of free space, that into Q1 by into Q2 by R221, like this we have to put. So this is the equation, and some remarks of this equation are relevant. They are relevant equations they are. So the valid for any sign Q1 and Q2, whether positive or negative, if Q1 and Q2 are the same sign, if they both are same sign, then F21 is along R21, which denotes repulsion. As that repulsion, the electrons is repulsive, which denotes us, they are saying. And the force acted on charge Q1 due to charge Q2 is obtained from example 1.3. F12 is equal to 1 by 4 by E0, or the permittative of free space, Q into Q1 into Q2 by R212, where R12 is equal to minus F21. Thus the Coulomb law agrees the Newton's third law. Newton's law for every action there is equal and opposite reaction. So Coulomb's law also reacts for Newton's law. And next is the questions. So this all you have to understand. Next is force between multiple charges. So how is the force between multiple charges? Multiple electron force between two charges is given by the, again, Coulomb's law only we will use to say. So as you know, Q1, Q2, like that we will take the Coulomb's law in the vacuum. So experimentally it is verified that force on any charge due to a number of other electrons is the vector sum of all the forces. So it is the vector force due to any charge is the vector sum of all the charges, and F12 into F12, as you know, F12 we got in the Coulomb's law. So therefore F12 is equal to 1 by 4 pi V0 is equal to Q1 by Q2 R212 and R12. This is the formula we got in Coulomb's law that we will use again here. And after using that, we will take F1 is equal to F12 plus F13. F13 we will put here again because F13, that is due to Q1 and due to Q3 we will put F13. After putting F13 we will do R12. What we will do means F1 is equal to F12 plus F13 is equal to 1 4 pi E0 or permutative quantity. Next F1 is equal to F12 plus F13 is equal to 1 4 pi V0, that is 4 1 by 4 pi V0 into Q1 into Q2 by R2 by 12 R12 plus 1 4 pi V0 into Q1 into Q2 R2 by 13 into R13. Like this you have to put the formula. Next is the questions for here they have given by using the formula to solve. Next is electric fields. See here one topic I left 1 minute only. So after F1 is equal to F12 plus F13 plus continuously and to the n number of it will going. So 1 4 5 0 12 13 till n number you have to put. Then we will get is Q1 by 4 pi V0. We will get, this is the formula you have to use to find the F to find that we have to use Q1 by or Q1 Q1 by 4 pi V0 into capital Q and small q by L square. L square is the formula you have to use to find it. Next is electric field. In electric field, in the vacuum at the origin O, if we place another point charge, Q at the point P where OP is equal to R, then the charge Q will exert the force on Q as per Coulomb's law. It will exert force on Q. So therefore it is equal to E by R is equal to 1 by 4 pi V0 by Q by R and 1 by 4 pi V0 by Q R square by R. This is the Coulomb's law, will write. There what will do means R is equal to R by R. R is equal to R by R we will put. R is equal to R by R is the unit we will put, and F is exerted by a change of Q on the charge Q. So therefore F is equal to 1 by 4 pi V0 Q, small q and capital Q and small q R square by into R we will put. So in the equation defines SI unit of electric field is N by C. Some of the important remarks of say are we can infer that if Q is unity, then the electric field due to charges Q is numerically equal to the force exerted. So electric field is numerically equal to the force exerted by them. And the next one is note that electric field is equal to electric field E due to Q through defined operations in the terms some test charge charge Q is independent of Q. So some test charges is independent of Q charges, and for a positive charge the electric field will be directly radial onwards from the charge, and on the other hand if the source charge is negative, then the electric field of vector at each point, so it is equal to the electric field. And saying the since the magnitude of the force on charge Q due to charge Q depends only on the distance or of the charge Q from charge Q, and the magnitude of the electric field E will also depend on the distance, or thus the equal distance from the charge Q. There will be equal distance from charge Q. The magnitude of its electric field is the magnitude also is same. So electric field due to a system of charge. So consider a system of charge Q1 Q2 with a positional vector R1 R2 and Let us go on the experiment. And positional vector is determined by denoted principal is determined by Q, and positional vector is determined by R. So this is the E1 is equal to 1 by 4 pi V0 by Q1 by Q of 12, or 12 is the Coulomb law we will put. And like that only E2 at R Q2, Q2 is at Q2 at R, R2 is. So we will here E1, here E2 we will put Q1 as Q2. If there is two lines, three lines is there means, like that only we will put, and therefore ER is equal to 1 4 by E0 by Q1 by R2 into Q1 by R2 is the formula we get. Next is physical significance of electric field. So you may have wondered that motion of electric field has been introduced here at all. After all, for any system of charges, the measurable quantity is the force on the charges which can be determined. So for electrostatics, the concept of electric field is convenient but not really necessary. So for the electrostatics, the concept of electric field is needed but not very necessary. It is not very necessary. And the term field in physics generally refers to the quantity that is defined in every point in space, and may vary from one point to another point in a difference. So again we will take Q1 and Q2 as the accelerated motion, and let us take C as the speed of light. And there will be some of the time delay between the effect and causes the motion of Q1, and thus the concepts of field was first introduced by Faraday, and it's now among the central concepts of physics. So this is some formula you have to use, and this you have to solve the sum. So okay friends, I will explain the next topic in the next video of this electric charges and field chapter. So till you understand, I think so. So like the video, comment on your and subscribe my channel and coaching for more video. Okay friends, bye. So take a rest in the next video. Till then, take care and have a nice day. Bye friends.